Now let us talk about the fourth case of the position of object placed in front of convex lens. The fourth case is, as we are moving towards the lens, towards the optical center of this lens, the fourth case becomes when the object is placed between center of curvature, which is written as 2f1, and the first focus point f1. This is our object, the dark arrow standing on the principal axis. Now, this value, the distance of first focus point from the optical center is 5 cm, as we have considered for all theoretical questions. Assuming that no data has been given, it is a theoretical question, but still the question asks you about the size of nature and where the image is being formed, direct, virtual, real, etc., etc. Now this distance is 5 cm and the distance of 2f1 from optical center is 10 cm. And if this object is placed between 2f1 and f1, it means it should be between 5 and 10. Let us assume it to be 7.5, and since this point lies on negative x-axis, so this point should be negative, it means minus 7.5. Minus 7.5. Now let us see what the value of V comes out to be from lens formula. If I write the lens formula, that is 1 by V minus 1 by U is equal to 1 by F, correct? And if I substitute the values of U and F in this formula, then it becomes 1 by V minus 1 by minus 7.5 is equal to 1 by 5. Do not forget, in every case I am mentioning, you have to take focal length as to be positive, because we are talking about convex lens. And even if it is mirror, convex mirror, you have to take focal length as positive. If you hear or read convex, doesn't matter lens or mirror, you have to take focal length as positive. So if I calculate V from here, this minus gets cancelled, becomes positive. So this can be written as 1 by V plus 1 by 7.5 is equal to 1 by 5. If I take this positive fraction on the left hand side to right hand side, it will become negative. So it can be written as 1 by V is equal to 1 by 5 minus 1 by 7.5. And if you remember, we have seen in mirrors also, we have seen in earlier 3 cases of lens also, convex lens, how to solve these fractions. You can multiply the denominator of the second fraction with the numerator of first fraction, and the denominator of first fraction with the numerator of second fraction. Then this becomes 7.5 minus 5 upon 7.5 into 5. So this becomes 1 by V is equal to 7.5 minus 5 is 2.5, 2.5 upon 7.5 into 5. Now 2.5 into 3 is 7.5, as 25 into 3 is 75. So 2.5 into 3 becomes 7.5. So V becomes simply 15 centimeters. Why? Because 1 by V is coming out to be 1 by 3 into 5, that is 1 by 15. If you invert the fraction, V becomes 15 centimeters. So finally, we have got the value of V. We have got the value of V, which is coming out to be positive 15. Now, similarly as we have done in previous cases, we will try to locate this point on positive or negative x-axis, that is principal axis. Since this is positive number 15, and since f2 is 5 centimeters, 2f2 is 10, definitely then it means 15 should be somewhere here, correct? It means the image is forming on positive x-axis beyond 2f2. Why? Because distance of 2f2 from optical center is 10 units centimeters. So 15 should be obviously beyond 2f2. So the very first result which we can write is image formed beyond 2f2. I hope you appreciate that is what the result you can see in that tabular form of different cases of position of object placed in front of convex lens. For this fourth case, when the object is placed between two f1 and f1, the image is formed beyond 2f2. The second result, which we have seen earlier also, if the image is formed on the other side where the object has been placed, it means both are on the either sides of this lens, or in other words, if the image is formed on positive x-axis or behind convex lens, then the image is real. Like we have seen in earlier cases also, in all the earlier cases of this particular convex lens, it was turning out to be real image. In this case also, image is formed behind the lens, so image is real. So second result, what we can write is real image. So like previous also, we using lens formula, we have calculated two results. First is position of image, that is forming beyond 2f2, that is what I have written here, image formed beyond 2f2. That is what you can see in the textbook, that tabular form of convex lens cases also. And since the image is forming behind the lens or on positive x-axis, the image is real. Now let us see what are the two results left and how we can calculate it using magnification formula, like we have done in earlier cases also. If I write magnification formula here, h2 by h1 is equal to v by u, and if I substitute the values of v and u, I have taken it to be minus 7.5, because this particular case is the object is placed between f1 and 2f1, and since f1 is 5 centimeters away from optical center and 2f1 is 10 centimeters away from optical center, that definitely means you can take any value between 5 and 10. For convenience, for the sake of convenience of calculation, I have taken it to be 7.5, and since this lies on negative x-axis, this point lies on negative x-axis, that is why I have taken the distance as minus 7.5. So if I substitute the values of v and u, h2 by h1 is equal to value of v, we have seen it comes out to 15 centimeters. I can substitute 15 over here. U is minus 7.5. Correct? Now 7.5 into 2 is 15, so this h2 becomes, h2 is equal to minus twice of h1. That means by seeing this calculation, I can say height of image is twice of height of object, but the length is negative. It means since we calculate the height of object and height of image on y-axis, this height we calculate on y-axis, this is positive because the image is lying above, the object is lying above the principal axis, and since the image is, height of image is turning out to be negative, it means you have to calculate the height of image on negative y-axis. Correct? So the two results which we can write over here is, if you remember, I will love to take the example again. If I have 100 rupees and you have twice the value which I have, it means you will be having 200 rupees. It means the output is double of what I am having, or the output is double of the input, or in other words, the height of image will be twice of the height of object, or we can better dictate or state that as the height will be magnified. So we can say height of image is double height of object, or in other words, magnified. Correct? Magnified image. And the second result, since this value is turning out to be negative, and it means you have to calculate the length or the height of the image along negative y-axis, it means the image should be inverted. So second result, what we can write is inverted image. So finally, using lens formula and magnification formula for this particular case, we have found the four results. Two results using lens formula and two results using magnification formula. I would like to repeat the case again. If the object is placed between f1 and 2f1, that is our fourth case. We are coming from infinity, very far distance. with the very first case. The second case was the object is placed just before 2f1, or in other words beyond 2f1. The third case was the object is placed at 2f1, and as we move towards optical center, the fourth case will become the object is placed between 2f1 and f1. That is why I have drawn the arrow as the object between 2f1 and f1. And since this value is 5 and this value is 10, as I have taken, and I suggest you also to take the same value, because the calculation becomes easy for theoretical question where the data has not been mentioned, that are numericals where data has been given. Whatever the data has been given in numericals, that you have to take. But for theoretical question, the calculation becomes easy when you take r is equal to 10 and f becomes 5 automatically. So I have taken this distance of object from optical center as minus 7.5, that is between minus 5 and minus 10, and using lens formula I have calculated the first two results, that is where the image is being formed, that is the value of v is coming out to 15 as I substitute the values of u and f in lens formula. It means since 2f2 is 10 centimeters away from optical center, then it means image is being formed beyond 2f2, and that is what I have written, image is formed beyond 2f2. The second result from the same formula, since the image is formed behind the lens, image is real. And using magnification formula, h2 by h1 is equal to v by u, where h2 is height of image, h1 is height of object, v and u are distances of image from the optical center and distance of object from the optical center respectively. I substitute those values and I have found h2 is equal to negative of twice h1. In magnitude it is twice of h1, it means image is magnified. If the object is this much, image is magnified and almost double here. And since the value is negative, I can say the image is inverted. So this was the fourth case. Now let us move further towards the optical center and see what can be the fifth case or what will be the fifth case. Obviously if I move towards the optical center, the next point I coincide or meet is f1, that is the first focus point, and the object should be placed at f1 or the first focus point to be as the fifth case of cases of position object placed in front of convex lens. So the fifth case is the object is placed at focus point f1 in front of the convex lens. Now coincidentally, this distance for theoretical question we have taken as 5 centimeters. We have taken as 5 centimeters. And since the object is itself placed on focus point f1, it means the distance of this object from optical center also becomes 5 centimeters. But since this point is lying on negative x-axis, it means it should be minus 5, correct? So I will take u as minus 5 itself directly, okay, and see how the four results using two formula comes out to be. The very first formula, that is 1 by v is minus 1 by u is equal to 1 by f. If I substitute the values of u and f, it becomes 1 by v minus 1 by 5 is equal to 1 by 5. This minus gets cancelled, so it becomes positive. If I take this positive fraction on the right hand side, it will become negative. So 1 by v is equal to 1 by 5, which was already present on the right hand side, minus what I have brought from left hand side. Since the same numbers are being subtracted, so it becomes 0. It means 1 by v is equal to 0 or v is equal to 1 by 0. Now what is 1 by 0? Friends, you remember that is any number upon 0 is infinity. It means the value of v is coming out to be infinity. Correct? So finally we have calculated the value of distance of image from optical center, that is v, and it is coming out to be infinity, positive. So if I try to locate this point, where this point is lying on principal axis or positive or negative axis. Now this is optical center, this is 5, this is 10, 15, 20, 30, 40 and so and so. It means infinity is somewhere very far. If I extend this x-axis, it means very far, somewhere here, infinity, very far distance. So the first result which I can write is image formed at infinity. Correct? That is what the result you can see in that tabular form of different cases of position of object placed in front of a convex lens. Second, since this value is turning out to be positive, doesn't matter very large number, but still it is turning out to be positive, it means this point should lie somewhere on positive x-axis, and since this point is lying on positive x-axis, it means the image is formed behind the convex lens. And since the image is formed behind the convex lens, one more time, the image should be real image. Right? So we have two results, image formed at infinity and the image is real since it is formed behind the convex lens using lens formula. Now if we use magnification formula, that is h2 by h1 is equal to v by u, and if we substitute the values of v and u in this formula, u we have taken it to be -5. Why -5? Because the object is placed at f1 and for theoretical questions where no data has been given, for the sake of convenience of calculation, we have taken r as 10 and focal length as 5. So it means if the object is placed at the focus point itself, the distance should be 5 itself of the object from the principal focus, optical center, and since this point is lying on negative x-axis, so this value will be -5 and v is coming out to be infinity. So if I substitute these values, h2 by h1 becomes infinity upon -5. Correct? Now infinity upon any number will be infinity. If you divide a very large number with a small number, the result will be a very large number. But because of this negative value, it will be a negative large number, a large number with a negative sign. So this h2 by h1 becomes minus infinity. Correct? Or in other words, h2 is equal to minus infinity times h1. So if I try to draw two results using this calculation which I have done using magnification formula, what results I can draw? Now let me take that rupees example once again. If I have 100 rupees and you are having a number multiplied with 100 that is very large, it means you will be having lots of money, or the value or the amount of money will be very large. Similarly, height of the object is h1 and it is being multiplied with infinity, which means a very large number. So it means the height of image should be very large in comparison to the height of object. But since this value is coming out to be negative infinity, it means it will be measured along negative y-axis but not positive y-axis, since the height of image and object are measured along y-axis and v and u along x-axis. So the very first result which we can write it as image is highly magnified. Since the magnitude of height of image is very large in comparison to the height of object, we can say the image is highly magnified. But at the same time, since this value is turning out to be negative, it means once again this image is inverted and not erect. So we can write inverted image. Correct? So let us see this case once again in a quick session of time. The fifth case is the object is placed at the focus point f1 in front of this convex lens. For theoretical question we have assumed, I repeat, for theoretical question we have assumed that r, for the sake of convenience of calculation, take r is equal to 10, so f becomes 5. It means f1 is 5 units away from this optical center. So since this point is lying on negative x-axis, it should be minus 5, and since the object is placed at this point itself, the distance of object from optical center should be taken to be minus 5, since the focal length is 5 for theoretical calculation we have considered. Using lens formula 1 by v minus 1 by u is equal to 1 by f, I have substituted the values of u and f. F assumed to be 5, and since the object is placed at the focus point f1 itself, u also becomes minus 5. After substitution and calculation, we have seen v is turning out to be infinity, a very large number. So it means, and it is positive, so it means the image is formed on positive x-axis because the number is positive, but at a very far distance because the number is very large, and v is supposed to be calculated along principal axis. So the first two results I have written as image is being formed at infinity, a very far distance behind the lens, and since the image is formed behind the lens, image is real. So first two results using lens formula. The next two results we have calculated once again using magnification formula, that is h2 by h1 is equal to v by u. Now v is coming out to be infinity, u we have assumed to be minus 5 since the object is placed at focus point itself. After substituting the values of v and u, this number is turning out to be negative of infinity because minus sign is involved in the denominator because of minus 5. Now if I take h1 on the right hand side, h2 becomes minus of infinity times h1. Whatever the height of object may be, it is going to be multiplied with a very large number, that is infinity. So height of image should be also very huge or large. But since it is having a negative sign, it means its height will be calculated along negative y-axis, not positive y-axis. So the very first result we can say is image is highly magnified because height of object is being multiplied with a very large number. And because it is negative sign there, so we can say the height is going to measure along negative y-axis, so it will be inverted image. So if I try to draw the image here, I can say it is a inverted but very large image. It's a very large image in comparison to the height of the object. So this was the fifth case. Now as we move towards the optical center, there is only one point which is possible. The object should be placed between f1 and optical center O. Let us see what are the four results we can get in this particular case as the last case of the position of object placed in front of convex lens. So as we move towards the optical center, the last possible case is object placed between focus point f1 and optical center O. Correct? So far we have seen previous 5 cases. We have seen every time the result was the image is real and inverted. Let us see whether it comes out to be in 6th case also, or it is going to be different in this particular case. The very first case was the object is placed at infinity as we moved towards the optical center. The second case, possible second case, was the object placed just before 2f1, or in other words beyond 2f1. Third case, the object is placed at 2f1. Fourth case, the object is placed between f1 and 2f1. Fifth case, just we have seen the object is placed at f1. And the sixth possible case, the object is placed between f1 and optical center O on the principal axis. Now since this point f1 is 5 units away from optical center, or in other words, since this point f1 is minus 5, as for theoretical questions, I repeat, for theoretical questions where data has not been given, I am not talking about numericals, but theoretical question where data has not been given, but since still it asks about size of nature, size or nature of image, position of image, the image is real or virtual, etc, etc. Then if we assume r is equal to 10 or f is equal to 5, then it becomes easy to calculate and answer those questions, those theoretical questions. So since this point f1 is minus 5, this is origin, O is origin, and the object is between minus 5 and O. So let us assume this distance to be minus 2.5. Correct? Minus 2.5 lies between minus 5 and optical center O. Now once again we will use lens formula and see what are the first two results which we can get. 1 by V minus 1 by U is equal to 1 by F. If I substitute the values of U and F, 1 by V minus 1 by U is minus 2.5, and like every case, since the focal length of convex lens should be positive, and since we have assumed for theoretical question R is equal to 10, it means F is equal to 5. So I have substitute F is equal to 5 on the right hand side of this lens formula. This minus gets cancelled, the fraction on the left hand side becomes positive, 1 by 2.5. So 1 by V plus 1 by 2.5 is equal to 1 by 5. If I take this positive fraction on the right hand side, it will become negative. So 1 by V is equal to 1 by 5 minus 1 by 2.5. And like in all the cases, doesn't matter in mirrors or lens, we have calculated these type of fractions. Again we will do in the same manner. We will multiply 2.5 with the numerator of first fraction and 5 with the numerator of the second fraction and denominator with each other. So this will become 2.5 minus 5 by 5 into 2.5. Correct? Now 2.5 minus 5 is minus 2.5. So 1 by V is equal to minus 2.5 upon 5 into 2.5. So this 2.5 gets cancelled. So 1 by V becomes just minus 1 by 5. If we invert the fractions, V becomes minus 5 centimeters or units, whatever you assume. So V is turning out to be minus 5, and this is the very first case among the 6 cases which we have seen. This is the 6th case where the first time we are seeing V to be negative. Now since V is coming out to minus 5 or negative value, let us try to locate this point on principal axis or negative or positive axis. Since this value is negative, definitely we will go to the negative axis, negative x-axis. Now f1 is minus 5, 2f1 is minus 10, that is what we have assumed, and this value V is also coming out to be minus 5. It means the image should form at f1. Correct? Why? Because this point is 5 units away from optical center O, and since this point is lying on negative x-axis, it should be minus 5, and also V is coming out to be minus 5. It means the image should form exactly at focus point f1. So the very first result which we can write from the calculation we have done using lens formula is image formed at f1. Correct? Now for the very first time in all the cases, the image is forming exactly on the same side where the object is placed, or in other words, the image is forming in front of the lens for the first time among the 6 cases what we have seen. In all the cases we were getting real image. Why? Because image was forming behind the lens, but this time for the very first time it is forming in front of the lens. It means this image should not be real and it should be virtual. That is why the second result which we can write is virtual image. Correct? So using lens formula for the last case, 6th case, we have got 2 results. Image formed at focus point f1, and since it is forming in front of the lens itself or at the same side where the object is placed, this image should be virtual. Now if I use magnification formula for this last case, h2 by h1 is equal to v by u, and substitute the values of V and U in this magnificent formula, then it says H2 by H1 is equal to, value of V is coming out to be -5, so I will substitute -5 here, and value of U I have taken to be -2.5. Why? Because it is being kept between F1 and optical center O. Optical center O is origin and F1 is -5. So I can take any number, any value between -5 and 0. I have taken -2.5 for the sake of convenience of calculation. So I will substitute -2.5 here. Correct? This minus gets cancelled. 2.5 into 2 is 5. So I can write H2 is equal to twice H1 if I take H1 on the right hand side. So finally I have got the height of image is twice the height of object, and also this time, for the very first time, it is coming to be positive value. If you see this value H2 is equal to twice H1, this value is positive. Now since the height of image is double the height of object, then definitely I can say the image is magnified. Correct? And since for the first time this value is coming out to be positive, it means the height of the object, height of the image rather, this time will be calculated along positive x-axis, positive y-axis. Since this value of H2 is coming out to be positive for the very first time, it means the height of image this time will be calculated along positive y-axis. If this length or the height will be calculated along positive y-axis, then it means the image is erect and not inverted. This is erect and this is inverted. So I can say image is erect. Correct? So if I want to draw the image here which is being formed at F1, then I can draw it somewhat like this. If this is the height of the object, this dark arrow as the height of the object, then this dotted arrow which is almost double the height of the object, and this is double the height of the object and erect also. Correct? So this was the sixth case, the last case of position of object in front of convex lens. We have seen 6 different cases. The very first case was the object is placed at a very far distance from the convex lens, that is at infinity. We have calculated and we have seen how for theoretical equation, by assuming r is equal to 10 and f is equal to 5. Why 10 and 5? Because it makes our calculation easy, and since the question is theoretical, no data, no value has been given, but still it asks about size of image, nature of image, real, virtual, etc., etc. Then we can always assume, for making our calculation easy, we can always assume r is equal to 10, so f is equal to 5, and by taking different cases, whatever the question is, theoretical question is. The first case, the object placed at infinity, we have seen the 4 results. The second case, the object placed just before 2f1, or in other words beyond 2f1. Third case, the object is placed at 2f1. Fourth case, the object is placed between 2f1 and f1. Fifth case, the object is placed at f1. And sixth case, this particular case, when the object is placed between f1 and optical center O. So I will repeat this last case. I have taken U as -2.5 because f1 is -5, O is 0. So any number I can take. For the convenience of calculation, I have taken U as -2.5. Why minus? Because this point lies on negative x-axis. Using lens formula, I have calculated the first 2 results. I have substituted the values of U and F. Don't forget, the word convex says doesn't matter mirror or lens, the focal length should always be positive. So I have substituted 5 for focal length and -2.5 in place of U. I have done the calculation and found V is equal to minus 5. For the first time in all 6 cases, this value is coming to be negative. It means the image is going to form on negative x-axis, and since f1 is the minus 5 point, the image is forming at f1 itself. So first result which we can write is image formed at f1, and since this image is forming on the same side where the object is placed, or in other words it is forming in front of the mirror, we can say this particular time the image is virtual. If I use magnification formula h2 by h1, that is equal to v by u, and substitute the values of v and u, that is minus 5 as v and minus 2.5 as u, h2 is coming out to be twice of h1, and this is a positive value, not a negative value. Since h2 is twice of h1, or height of image is double the height of object, it means the image is magnified. That is what I have written, image is magnified, correct? And since this value is positive, so the height of image will be calculated along positive y-axis, because positive y-axis will give positive values of height of image, correct? That is why I have written image is erect. So far we have seen 6 different cases of position of object placed in front of convex lens. Like we have done in mirror case also, concave mirror and convex mirror, we have seen for theoretical question how easily our calculation can be done if we assume r is equal to 10 and f is equal to 5 for theoretical questions, and calculate the 4 results, that is size of image, nature of image, where it has been formed, etc., etc. Correct? And in the same way we have done in convex lens also. After doing the same calculation for theoretical question in concave mirror, we have seen ray diagrams, and we have repeated the 6 cases and seen how we can draw the ray diagrams for 6 different cases in case of concave mirror. Here also we have seen 6 cases in when the object is placed in front of convex lens, how easily for theoretical question by assuming r is equal to 10 and f is equal to 5 we can get all the 4 results in a very quick session of time. And now we will again repeat these cases and see how ray diagrams for these 6 cases can be drawn after we learn the rules for drawing ray diagrams for these particular cases.